Hello all, let's start part 2 of the lecture of 7.2. In this part, I will cover if we know the margin of error, if the margin of error is given to us, how to find the sample size. In this case, I will write finding required sample size. Finding required sample size. If E is given, if E is given, correct? Look, our formula for margin of error was E equals Z alpha over 2, correct? The square root of P hat Q hat over N. That was our formula for the margin of error. I'll do here some math for you. I will solve this equation for N, but again, you are not required to learn how to find the N. After I found a formula for N, I will show how you can find a formula for N. You just use that formula, or not all the steps, or not all the algebra that I will do here, correct? But I will show you anyway how to find from this given formula, which is E equals this, how to find N, correct? The first step to solve this equation for N, I will divide both sides by Z alpha over 2. It means I will multiply here with 1 over Z alpha over 2, this side, and I will multiply the same amount on this side, Z alpha over 2, correct? Doing that, you see these two cancels out and you end up with E over Z alpha over 2 equals square root of P hat Q hat over N. Now, next step to solve for N, I will square both sides. Why I am squaring both sides? Because I want to remove the square root sign from that side, correct? And if I do this, you will see square cancels out with the square root and you end up with E squared over Z alpha over 2 squared equals P hat Q hat over N, correct? Now, using the techniques of algebra, I can bring the E here and I can move the N there, correct? In this case, I will end up with N over Z alpha over 2 all squared, or Z alpha over 2 squared, equals P hat Q hat over E squared, correct? One more step. I have to have N alone on this side, then I will multiply both sides by Z alpha over 2 squared. I will multiply this side and I will multiply this side with Z alpha over 2 squared, correct? You see these two cancels out. Then I can create a formula for you. This is the formula that you have to learn. N equals Z alpha over 2 squared P hat Q hat over E squared. That will be the formula that we are using to find the sample size if the margin of error is given to us, correct? We know what is P hat, we know what is Q hat. There is a worst case scenario. The worst case scenario is that if you don't know the probability of success, if you don't know your P hat and if you don't know your Q hat, in this case, what we do, we calculate p hat as a 50% chance, 0.5, and also we calculate q hat as a 50% chance, because if p hat is 0.5, then q hat is also 0.5. You see, if I multiply these two, it gives me 0.5 times 0.5, correct? Which is 0.25, correct? After multiplying, 0.25. If I bring this number here in this formula, then I can create another one, n equals z alpha over 2 all square times 0.25 over e square. When you use this formula, when p hat is not given to you. If you have the p hat, use this one, find the sample size. If you don't have the p hat, then use this one, you can find the sample size, right? I will do two examples for you, and I'll use in these two examples both formulas for you to show how to use them. Example number one. We want to determine the percentage of US people, of United States people who used email at 95% confidence level. What does the sample size needed to be ensure a margin of error of 4%. I put one direction for example number one because I will use the same example for example number two, but here the last part of the example for example number one is like this: 16.9% of people used email in 1997. Correct? In part two, I'll just change the last part. In example number two, I'll just change the last part of this example. Correct? The first thing to do is identify. Correct? Of course, what sample size needed? You're looking after n. Correct? How much is my p hat? The probability of success. Correct? The probability of success should be given somewhere in this problem. You see, 16.9% people used email in 1997. That's your p hat. If you change 16.9 to decimal, it gives you 0.169. If I know p hat is 0.169, then q hat is equal 1 minus 0.169, which gives you 0.831. 0.831. Correct? Now I need my Z alpha over 2. Z alpha over 2, from where I can find Z alpha over 2? 95% confidence level. You know your Z alpha over 2 for 95% is 1.69, correct? Your critical value is 1.96, correct? And also the margin of error is given to you as a 4%, you see? It means 0.04 here, correct? Change it to decimal. Now, I have all these values. I'll use the N formula and easily I can calculate the sample size, correct? N equals, my formula is Z alpha over 2 squared P hat Q hat over E squared. Just plug in the numbers in, it gives you 1.96, your Z alpha over 2 squared. Do not forget to square it, times your P hat 0.169 times Q hat 0.831 all over E squared 0.04 all square. Now using your calculator, square this number, multiply all the three numbers in the top, but first square 1.96, then multiply the three numbers in the top, square the denominator, and then divide. And if you do so, you will end up with N equals 337.19. That will be your sample size. Because you are dealing with human being, you cannot have a decimal. You can just round up to 338 people. Your sample size should be 338 people to make sure to get the margin of error of 4%. Correct? Now, in example number 2, I'll just change the last part. The first part of the example is the same thing, correct? I'll change just the last part. I'll put 2, assume we know nothing about percentage percentage of email usage. Correct? It means I don't have here P hat, Q hat. Again, I know my N, correct? Which is, I have to find it, correct? P hat, I don't know. Q hat, I don't know. It's not given. If P hat is unknown, Q hat is also unknown. Again, Z alpha over 2 will be the same, 1.96, correct? Margin of error will be the same, 0.04, correct? In this case, easily you can use the second formula, which is N equals Z alpha over 2 square times 0.25, because P hat Q hat is not, we don't know it, we just put 0.25 over E square 0.04 all square, correct? And if you do the calculation, let me put also my Z alpha over 2. I know the value, which is 1.96, correct? 1.96 square. And if you do this calculation, then N equals 600.25. Again, because you're dealing with human beings, it cannot be decimal. You can write as a 601. Your sample size should be 601. There is a difference. There it's 338 for sample size, because we know exactly 16% of the, told us that 16.9% of people in 1997 used email, correct? We know exactly the probability of success. But here in part 2, our sample size is bigger because what we did, we counted 50% for our p hat, correct? 0.5 means 50%. 50% of people used. It's way, I'm sorry, way different than 16%, right? 50% is too much. That's why you see your sample size is growing bigger, right? This is how you calculate the sample size if the margin of error is given. Last part of the lecture, finding p hat, finding p hat, q hat, and e if confidence interval is given. We know our confidence interval is p. On this side you have p hat plus e, and on this side you have p hat minus e. If I give you this confidence interval, it means if you have a number on this side and a number on this side, you can find the value of p hat. Even you can find the value of e, margin of error. And of course, if you can find the value of p hat, it's really easy to find the value of q hat. That means the probability of failure, correct? Let's create two formulas for this. I'll do some math here. Look, this side we call it upper. I'll take the upper limit, which is p hat plus e, and I'll add this one with lower limit, which is p hat minus e, correct? And I'm looking to find p hat, the value of p hat. Look, if you do this math, what's happening? Let's see. P hat equals p hat plus e plus p hat minus e. You see, easily e's are canceling out. Then you end up p hat, and on this side 2p hat. To make this as an equation, to put equal sign, then I have to divide this side by 2 to get rid of this 2. It means here at the beginning I have to divide it by 2 to get p hat, correct? Now, you don't need to memorize this. You need to memorize this. I just showed to you how. If you want to find p hat, the probability of success, always add the upper plus lower, divide by 2. That will be your formula to find p hat. And if you could find p hat, then q hat equals 1 minus p hat, right? Now, to find e, correct? To find e, again, I'll take the upper limit, which is p hat plus e, and I'll subtract the lower limit. This time I will subtract the lower limit, which is p hat minus e, correct? You see, if you distribute the negative here and simplify, you end up with p hat plus e minus p hat plus e. P hat and p hat cancels out, it gives you 2e. To make it again equal, because you need an e, you have to divide by 2. It means here you have to divide by 2, correct? Then I can create this formula for you. To find the margin of error, if the confidence interval is given, it will be upper limit minus lower limit divide by what? By 2. Very easy, two things to remember. Don't worry about the left side. The one that I put inside the box, those are the important ones. You have to memorize them. Correct? Now, let's do an example for this. Then I'll stop the lecture for you. Example. The confidence interval is given 95%. You're working with the 9% confidence interval, correct? And your P is between less than 0.81 greater than 0.58. They are asking you to find here P hat, find Q hat, and also find margin of error. Very easy. First, P hat. P hat equals upper plus lower divide by 2. It means this is my upper limit, 0.81, plus my lower limit is 0.58 divide by what? 2, which you end up with, if you do the math, 0.695, correct? Which is 69.5% in percentage. To find E, of course, when you find Q, Q hat equals 1 minus P hat, right? It means 1 minus 0.695. And you can use your calculator. Easily you can find the value. To bring up the calculator, let's see. 1. Let's clear first. There are some data. One minus 0.695. 0.695, which is equal to 0.305. 0.305. That will be your Q. Correct? Now, calculating margin of error. E equals upper minus lower this time divide by what? By 2, which is equal 0.81 minus 0.58 divide by what? By 2. And if you do the math, it gives you 0.115 will be 11.5% margin of error if you want to change it to percentage, right? 11.5% will be your margin of error. I'll stop the lecture here. See you all in section 7.2.